Thank you very much for the opportunity to present a new, exciting application of hydrothermal carbonization, carbon dioxide removal. In this presentation, I will refer to our technology as wet pyrolysis, because pyrolysis is widely known in the CDR industry, and it clearly shows differentiation by being able to utilize moist biomass and even sludge in a very effective way for climate protection. With this technology, we are addressing a problem around organic waste streams and turning it into a climate solution. First of all, we avoid greenhouse gas emissions from organic waste, for example on landfill sites. Here specifically nitrous oxide and methane, both very aggressive greenhouse gases. And secondly, we remove the carbon from the carbon cycle and store it safely in hydrochar. We essentially turn back the carbon cycle. This graphic demonstrates how we extract wet organic residues from the carbon cycle and avoid the release of CO2 and other greenhouse gases back into the atmosphere. We treat it in our TerraNova Ultra plant performing wet pyrolysis and generate stable hydrochar containing the carbon of the input biomass. This hydrochar is safely stored underground, where it sequesters the carbon for several hundred years. This is a short recap of the TerraNova Ultra technology. It represents a technology platform for CDR, but also for the recovery of phosphorus and nitrogen for the production of soil conditioner or renewable fuel. The magic about it is that the final product hydrochar stores more than 90% of the input biomass carbon. But how can we reach this high carbon efficiency? We recover the process water carbon within the process, so it ends up in the hydrochar. This enables high CO2 credits in each ton of TerraNova hydrochar. The market for carbon dioxide removal is very dynamic, and it will triple in size within the next few years. Currently, more than 90% of the carbon credits are based on pyrolysis projects, mostly using dry wood. We offer here an attractive alternative with even lower cost. Depending on the project, I project the cost to be less than $200 per ton of CO2. This is at the lowest range of all CDR technologies known to the market right now. Here another graphic demonstrates the dramatic gap between CDR demand and supply in the future. Our technology will greatly help to close this gap. Our TerraNova wet pyrolysis process offers significant advantages as CDR technology. First of all, it is very versatile regarding the input material. Whatever organic leftover there is, we probably can use it. Second, our technology has a very high carbon efficiency. Third advantage is we have a stable and secure sequestration of CO2. Furthermore, our technology has a very low energy demand and low specific cost per ton of CO2. And we are able to use waste heat or even solar heat to power the process. Now I would like to address one topic, and this is the stability of hydrochar. The stability of the hydrochar coming out of the TerraNova Ultra process is comparable to lignite coal. Lignite coal is safely storing CO2 over the last million of years. We could easily use abandoned coal mines to reuse it to sequester carbon in the future. This table shows the elementary analysis and demonstrating that chemically both lignite coal and hydrochar are very similar. Let me add some comments regarding the stability of hydrochar. First of all, the stability can be adjusted by process conditions in a certain range. While the yield of hydrochar decreases with more severe process conditions, the stability, and in this case we have the hydrogen to carbon ratio as a measure, increases. So in general, we have some flexibility to adjust to the demand. But most importantly, if applied in real soil, recent research proves that hydrochar greenhouse gas emissions are comparable or even lower compared to char from pyrolysis and gasifiers. The left graphic shows similar long-term release of CO2 compared to conventional char. Hydrochar even shows clear advantages in terms of long-term nitrous oxide emissions. This is shown on the right-hand side graphic. So the stability of hydrochar, even compared to biochar from pyrolysis or gasification, is much better than we think. Furthermore, I would like to stress the point of carbon efficiency. During the gasification and pyrolysis process, already a large part of the biomass carbon is emitted and lost for CDR. This char, so to say, starts from a much lower carbon level compared to hydrochar. Now I have exciting news from Europe. A new legal framework for CDR is in place since end of 2024. It offers 3 different ways how to comply for negative emission credits. The first way, and this is the fast track that I'm focusing on right now, is to produce hydrochar and put it safely away for several centuries, as I have explained before. The second way is carbon farming. And I'm aware that there is a lot of discussion about changing effects of biochar and hydrochar in different soils, so the whole thing might be a little bit more complicated and long-term. And the third way is what they call carbon storage in products, which is quite interesting. So for example, blending hydrochar or biochar into asphalt and concrete. So this is an application that is under research right now from a lot of companies. Certain quality criteria will be fulfilled by the TerraNova CDR projects. And these are the quantification of the net effect, the additionality of the project, reliable storage of the carbon, and the sustainability factor. Let me just add that our TerraNova project in Mexico City fulfills 15 of a total of 17 sustainability development goals of the United Nations. So we are very well prepared to build meaningful projects here. This project in Mexico City is a great showcase for efficient CDR. This is a picture of the complete plant, converting organic fraction of municipal solid waste into hydrochar. And here is a short video that I would like to show. This is the organic waste coming into the plant. This is the TerraNova Ultra hydrothermal carbonization plant with a vertical reactor. And this is the hydrochar as a final product of the process. So thank you very much for your attention, and I'm looking forward to an exciting future of hydrothermal carbonization as carbon dioxide removal technology. Thank you.